Welcome, 8th grade. Making decisions and predictions. All right. So today we have to decide on a few things when we do our permutations, our calculations. All right. They're not overly hard, but we may have to use cross products or other items like that, where you take x times 1.7, 1.7x, 6 times 5, so 30.6. Then you divide, you get your answer. You remember how to do the cross multiplication, cross multiply and divide? Hopefully you do, because that'll be something that we can use today. All right. Learn to use probability to make decisions and predictions. All right. The table shows the satisfaction rating in a business's survey of 500 customers. Of their 240,000 customers, how many should the business expect to be unsatisfied? So the total number of people in this customer survey was 500. That was the total. Total goes on the bottom. The people that are unsatisfied was 35. We're going to set that equal to the total customers they have overall and the number that would be unsatisfied here would be our variable. We have a cross multiply and then divide. So we're going to multiply 35 times 240,000 and 500 times u. Then we're going to divide by that 500 and divide by that 500, and we'll be able to get our answer. Or if you know that they're multiplying what they're multiplying here to get this, if it's times, I don't know, whatever it might be, then you can multiply the same thing up here and get u. But let's see what they do. Find the survey and unsatisfied customers. Number of customers unsatisfied in the survey, that goes on top. That's what meets our desired remarks. Then the total number in the survey, 35 over 500, or they reduced it down to 7 over 100. You can always reduce that down. So they're probably going to use a proportion setting up 7 over 100. Okay, that's going to be easier to divide by. Then we're going to cross multiply. 700 times 240,000, 100 times n. Then we're going to have to divide by that 100, right? And divide by that 100. Divide both sides by 100. You multiply this, you get that. Divided by 100. They can expect 16,800 people to be unsatisfied because this was their survey, and then they translated that or used it on their whole group to make a prediction of how many people would be unsatisfied. Okay? So, Jared randomly draws a card from a 52 card deck and tries to guess what it is. If he tried this trick 1,040 times over the course of his life, what is the best prediction for the amount of times it works? Okay. He draws one card out of a 52 card deck. Alright, so he's got a 1 in 52 chance of getting it right. His desired was that card that he drew. The total chances, there were 52 different cards. Now, what's the total times he tried it in his life? 1,040 times. We don't know how many times he got it right. We're going to be able to do our cross products. 1,040, 52x, do our divide by 52, our divide by 52, and we'll figure out x is, I can't do that math in my head, but I bet they'll show you what it is. So that's going to be able to help us predict how many times he did that trick right. All right, theoretical probability, number of possible outcomes, 1, the card he wanted. Total, 52 cards in the deck. All right, desired over total, always. Set up that proportion. Hey, they just wrote what I did. They did that multiplication, divide by that 52 because we want that n all by itself. N equals 20. So out of 1,040 times, he has the likelihood of getting it right 20 times. Not very good odds. All right. So we're back to this. We have another survey of 500 customers. That's the total people surveyed. And they want to know how many customers or how many businesses they should expect to be pleased. 125 are pleased out of 500 total. We're going to set that up. Well, how many total customers do they have? 240,000. How many do we plan to be pleased in that whole group? We're not sure right now. So we would do this. 500x 125 times 240,000. And then we'd be ready to do our math. We've got them here. These are huge numbers. Feel free to use what you need to use. Now, I will erase that, and then we'll see it a second time here in just a bit. So, number of customers pleased, that's what we want. That's the desired. Total number of customers surveyed, that was 500. They reduced it down to 1/4. Trust me, that'll make their math a lot easier than our math was going to be. Watch. So we set up a proportion. That 1/4, which is the same as that 125 over 500, all right, because they just reduced it down, equals the n over 240,000. Find the cross products, divide by 4, and they can expect 60,000 customers, or 1/4 of their customers, to be very pleased with their service. All right. Caitlin randomly draws a domino tile from an 18-piece set and tries to guess what it is. So there's one thing that she draws, and there's 18 possibilities. All right, she tries this trick 22,500 total times in her life. We want to know how many times she got it correct. We can again do our cross products. 18x equals 2,250 or 2,250. Divide by 18. X all by itself. Divide by 18. X equals 1 and 40. That'd be 2, 36. That'd be 90. That'd be 125. On my quick math there. All right. Let's see how we did. Desired over total. Desired over total. We can do our cross products. Let's see what we came up with. All right. Number of possible outcomes, 1 to be right. Possible outcomes total, 18. Can't reduce that, so we set this up. Hey, I think we did that before. They did the cross products, now they divide by 18, and they get 125 times that she would be right out of that 2,250 times. All right? So, in a game, 2 players each flip a coin. Player A wins if exactly one of the 2 coins is heads. Otherwise, player B wins. Determine whether the game is fair. So we have to think, there's 2 coins. So when we flip those 2 coins, player 1 and player 2 could get heads. Player 1 could get heads, player 2 could get tails. Player 1 could get tails, player 2 could get heads. And both of them could get tails. So there's 4 different outcomes. A total of 4, right? Now we have to decide if the game is fair. Well, player A wins if exactly one of the 2 coins is heads. How many situations where we have one of the 2 coins being heads? 1, 2. All right, so there's 2 of our desired outcomes. How many total outcomes are there? Hopefully you see 4. Now for player B, wins if otherwise. So if there aren't exactly 1 head and 1 tail. Or 1, Oh. So, not 1 head, not 1 head. So 2 out of 4. This is equal, and therefore the game is fair if they both have an equal chance of winning. We found out the total outcomes. We saw which one met for player A, which one met for player B, and we compared them. If they are equal, it's fair. If they're not, it is an unfair game. Okay. So, list all possible outcomes. There they are. Find the theoretical probability of each player winning. All right. Two probabilities where that 2/4 reduces down to 1/2. For player B, that 2/4 reduces down to 1/2. Both have the same odds. That is a fair game. In a new game, 2 players each flip a coin. Player A wins if at least one of the 2 coins is heads. Otherwise, player B wins. At least. That's important. So, heads, heads. Tails, heads. Heads, tails. Tails, tails. So, player A wins if at least one. A. There are 4 choices here. At least one is heads. There's at least one here, at least one here, and there's at least one here. Because if there's more than one heads, that's at least one. So player A has a 3 out of 4 chance of winning. Reading is important. That at least one makes the difference. Player B wins otherwise. That means if there's 2 tails, player B wins. 1 out of 4. This game favors player A a lot. It's unfair. All right, let's see what they do. List the possible outcomes. We did that. The theoretical probability. All right. There's 3 out of total 4 chances of the player A winning. And there's only 1 out of 4 for B. They're not equal. The game is not fair. Don't play. You guys and gals are ready to try this. I'm sure of it. All right. Call me with any questions or email me now that you can do that.